Okay, today's lesson is lesson 4-2. You have a notes handout for this lesson, and after this slide we're going to look at the notes handout exclusively from this point forward. Your objectives for today are to express relations in multiple representations, give the domain and range of relations and functions, and identify functions from ordered pairs and graphs. There are 7 examples total. So let's look at your handout. Alright, the first thing you need to do obviously is go ahead and put your name on your note sheet. We're going to look at the terms for these words from our lesson today so you understand exactly what we're dealing with here. The first term we're going to write down is relation. Relation is a set of ordered pairs. A relation is simply a set of ordered pairs. A set of ordered pairs. Domain is the set of x values. The set of x values or input values. The range, conversely, is the set of y values or output values. So you're writing all of this down on your handout. Again, the range is the set of y values or output values. And lastly, function is a relation in which every x is paired with exactly one y. A relation in which every x is paired with exactly one y. We're going to look a whole lot closer at exactly what that means in just a minute. If you have a hard time remembering that domain represents x and range represents y, it might be helpful for you to think about the alphabet. D comes before R, D comes before R, and X comes before Y. So they're both in alphabetical order. The next thing we're going to look at is some ordered pairs. So we're going to write down our ordered pairs right here on this blank. The first example we're going to look at is going to be a function because every x is paired with exactly one y. Let's see what that means. We're going to use our squigglies again. And we're going to put each of our ordered pairs in parentheses. So our first ordered pair is 1 and 6. Our second ordered pair is 2 and 5. And our third ordered pair is 6 and 5. Look at our x values. It's this one, and this one. These are our x values, 1, 2, and 6. Notice that our x's do not repeat. We have 1, 1, 1, 2, and 1, 6. Therefore, this is a function. Our x's don't repeat, and every x is paired with exactly one y. It doesn't matter that we have 2 5s. We have one x, our x's do not repeat. This example that I want you to copy down next is not a function. Our ordered pairs 5, 6, 7, 2, and 5, 8. Look at our x values. We have 5 and 5. Our x's repeat. Here it's paired with a 6 and here it's paired with an 8. This is not a function because we do not have exactly one every x paired with exactly one y. We're going to look at this next example. And don't stress over this. This seems to be a point of stress for us in the past. So don't stress over this, but we're just going to look at this. This is an example using children and mothers. Our children are our X's and our moms are our Y's. The first mapping scenario, I want you to draw an arrow from Jacob and Sarah to Ann. Jacob and Sarah are Ann's children. The next example, I want you to draw an arrow from Chase, Amber, and Cole to Lynn. Chase, Amber, and Cole are Lynn's children. This is valid. Two children can have the same birth mom. This is a function because two children can be born from the same mother. Now look at this example. Draw an arrow from Jacob, Sarah, and Chase to Ann. Now draw an arrow from Chase, Amber, and Cole to Lynn. The problem with this scenario is that Chase has two birth mothers. I'm not debating that you can't have two moms. I'm debating that you can't be born from two different women. Chase cannot be born from Ann and also from Lynn. So this is not a function. You cannot have two birth mothers. Another way to tell if something is a function is to do what we call the vertical line test. In the vertical line test, we simply draw a vertical line. And if the line passes through the graph at 2 points, it is not a function. We say fails the vertical line test. So, for our first example, we're going to draw a vertical line. You can draw a vertical line at any point on the graph. I'm going to go right here. So I want you to draw a vertical line. I'm using this piece of paper for my... Draw a vertical line. Draw it all the way through the graph. And you will notice that here and here, my vertical line passes through the graph. So we say this fails the vertical line test and it is not a function. I think the vertical line test is probably the most foolproof way to determine whether or not a graph is a function. You can't always use the vertical line test because you aren't always going to have a graph of your function to draw a line through. But if you do have a graph, this is definitely a good option for you. On the next one, we're going to draw a line. And I'm not drawing my line on my axis because I don't want to get confused about... Oh, that's not much of a vertical line, sorry. I'm not drawing my line on my axis because I don't want to get confused about whether or not it's my axis or my vertical line that I'm drawing. So here I can see that my line crosses through my graph at exactly 1 point. It does not cross through my graph again, and therefore this is a function. So you should be writing at the bottom whether or not it's a function. You should be drawing the vertical lines on your graphs. And I would like for you to circle the points where they intersect so you can refer back to that and see that you have 2 points of intersection there. All right, on our last vertical line test, again, I'm going to pick that same spot and draw a line. Try to draw a better line this time. Kind of. All right, and then you can see that it intersects with my graph here and here. And because it intersects in 2 points, it is not a function. So you need to write that in. All right, so make sure that you have the vertical line test drawn on each of those 3 graphs and that you have at the bottom whether or not they are a function. Okay, number 1. I know this is technically just number 1. I'm going to give you a set of data, and I'm going to give you the background behind the set of data, but you're not going to see that there on your worksheet, so just bear with me for a minute. There's a scoring system at a racetrack, and in this scoring system, they say that first place gets 5 points. Second place gets 3 points. Third place, 2 points. And fourth place, 1 point. With that said, this is what that looks like as a set of ordered pairs. First place, 5 points, 1 and 5. Second place, 3 points, 2 and 3. Third place, 2 points. Fourth place, 1 point, 4 and 1. Okay? So you should have that in your squigglies or your braces. You should have each of your ordered pairs in parentheses with a comma between your numbers and a comma between your ordered pairs. Now we're going to look at the domain and range and whether or not this is a function. My domain is simply my x values. My domain, again, according to my definitions up at the top of the page, the domain is the set of x values or input values. So I'm looking at my x's. I know in my ordered pairs that they're listed xy, 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 and you're welcome to label those if you would like to, if that makes more sense to you. So my domain is simply a list. I do put it in squigglies and I do put a comma between each number, but it is simply a list of my domain, my x values, from least to greatest. One, two, three, four. Those are my x values from least to greatest. My range is going to be my y values from least to greatest. So I'm going to start with the 1, 2, 3, 5. The biggest mistake that's made here is not listing them from least to greatest. Okay, I can look at my x values, 1, 2, 3, and 4, and see that they don't repeat. I have 4 pairs, 1, 2, 3, 4, and I have 4 x values. So yes, this is a function, and when I'm being asked to explain what I'm supposed to say here is the x values don't repeat. We're going to look at this set of data in a table, and then a graph, and then a mapping, and then we'll be able to do the vertical line test on our graph and make sure that it does pass the vertical line test as well. All right, so my x is 1, 2, 3, 4. My y's go with the x. They stay in their pairs here. So it's 1 and 5, 2 and 3, 3 and 2, 4 and 1. So my x's are listed least to greatest, but my y's stay in their ordered pairs. Now I'm going to graph this. My first ordered pair is 1 and 5. My second is 2 and 3. My third is 3 and 2. And my fourth is 4 and 1. I can draw a line. And no matter where I draw a vertical line on this graph, it's never going to cross 2 points at once. So I can draw a line anywhere I want, and it's still going to pass the vertical line test. So I'll draw a line right here. Show you that it only crosses 1 time. All right. Now let's look at our mapping. In my mapping, I'm going to list both my x's and my y's from least to greatest. 1, 2, 3, 4. 1, 2, 3, 5. And now, label your x and your y. I'm going to connect my ordered pairs. So 1 and 5 go together. 2 and 3 go together. 3 and 2 go together, and 4 and 1 go together. So you're going to draw a line to connect each of your ordered pairs. That is mapping. So we can also come back to our explanation here as to why this is a function, and we can say that it also passes. We call this the VLT. It's a whole lot easier to write VLT than it is to write out vertical line test. So we abbreviate vertical line test and say this is the VLT. So it passes the VLT.
All right, go ahead and flip over to the back of your worksheet. This is number 2. Your points are 2, 0, 1, -3, 0, -4, -2, 0, and -3, 4. I realize that's kind of hard to see. If those are your points, go ahead and make sure that you have those down. We're first going to look at the table. So the table, the X's need to be ordered from least to greatest. So we're going to go from least to greatest. And that's only the X's for the table that need to be ordered least to greatest. So to order these least to greatest, I'm going to look at my X's. My first one's -3. And then my Y that goes with -3 is 4. So -3, 4 is the first one. My next biggest one for my X values is -2. And it goes with 0. So -2, 0 is the next one. My next X value is 0. And it's 0, -4. The next one is 1. And then the -3 that goes with it. And then the 2. And then the 0. Biggest thing with the table is to remember that the X values need to be least to greatest. If you notice, it goes -3, -2, 0, 1, and 2. The Y values on the table are not ordered least to greatest. Then we're going to go through and plot the points. So -3, 4. It's going to be right here. And remember, it's always your X value and then your Y value. Then we have -2, 0. We have 0, -4. Then and then 1, -3. And then 2, 0. And again, all we're doing here is plotting those points. Please do not connect them with a line or anything. There's nothing there telling us that it's a line, so they are just points. All right, so we've done our table, we've done our graph. Now we're going to do our mapping. Mapping, it's important to remember that here's your X and here's your Y, but that both the X and the Y are both listed from least to greatest. It's also important to see that there should be no repeats. What the no repeats means is that if you have more than one number, you only write it down one time. So my X, it's going to be -3, -2, 0, 1, and 2. In my Y column, again, these this time need to be least to greatest, so it's going to be -4, -3, 0. Now I have 2 zeros over here for the Y column, so I'm only going to write that once here because, again, with mappings, there are no repeats. And then 4. And then I'm going to draw my arrows. All of my X's should be going to a Y here, so I have -3, 4. So I'm going to draw an arrow from my -3 to my 4. -2 goes to the 0. 0 goes to -4. 1 goes to -3. And the 2 is also going to the 0. So now we've done our table, our graph, and our mapping. Now we're going to come back over here and talk about domain and range. Just a second, I'm trying to get my paper line back up here, maybe. There we go. All right, domain. We're going to put our braces for our set notation here. We're going to list all of our domain values or our X values from least to greatest with no repeats. So domain and range, again, are least to greatest for X's and Y's, and there are no repeats. So -3, -2, 0, 1, and 2 for my domain. My range is going to be -4, -3, then 0, but again, I'm only going to write 0 one time because there's no repeats with domain and range. And then my 4, and then my braces. So you might want to tell yourself that this is least to greatest, and then there are no repeats in domain and range. So here, now we're going to answer the question of whether or not it's a function. Several different ways we can answer this. We can look at the X values and make sure none of them repeat. We could use the vertical line test on our graph. Or we can look at our mapping and make sure that each of the X's only has one arrow going from it. All of these cases are true. So it is a function. So I'm going to write yes for function, and then the explain, I'm going to say X values don't repeat. Or I could also say that it passes the VLT. Now, if I say that it passes the VLT, I have to have a graph to back that up, but I do here. I have this graph. So if you looked at the graph and used the vertical line test, you can put that it passes the VLT for your explanation. Make sure you have all that down. All right, number 3. Just a second. All right, now we're going to look at number 3. Your points for number 3 are -1 and 1.5, 3 and 1, -1 and -0.5, -4 and 1, and 1 and -1.5. All right, again, we're going to start with our table. Our X values here are going to be listed from least to greatest. So we're going to have -4, -1, -1, 1, and 3. And again, on a table, you do have repeating values on a table, just not on a mapping or domain and range. And we're going to put all of the Y's that go with each one of the different X's. So it's -4 and 1, -1 and -0.5, -1 and 1.5. And then 1. So here, it really doesn't matter. You could have these in different orders. Usually if I have the same X, then I make sure that the Y's are least to greatest. But again, that isn't really a big deal there. Now we're going to graph them, and here I'm actually going to go up by halves. So I'm going to make this my 1 and this my 2. This my -1 and this my -2. That way it's a little bit easier for me to graph by halves. So I'm going to go up by 0.5, 1, 1.5, and 2. My x-axis is just going to remain the same with 1, 2, 3. And then I'm going to plot my points. I have -4, 1, -1 and -0.5, -1 and 1.5, 1 and -1.5, and 3 and 1. So make sure you have each one of those listed. The mapping, your X is on the left, your Y is on the right. Again, remember that each of these are least to greatest, and that mappings have no repeating values. So when I write my X's, it's going to be -4, -1, I'm only going to write one time, 1 and 3. Then my y's this time need to be least to greatest, so I'm going to say negative 1.5, negative 0.5, 1, and even though 1 is listed twice, I only write it once with a mapping, and then 1.5. Then I'm going to draw my arrows. Negative 4 is going to the 1. Negative 1 is going to negative 0.5. Negative 1 is going to 1.5. 1 is going to negative 1.5, and the 3 is going to the 1. So there's my mapping. Now I'm going to go over here and state my domain and range. Again, domain and range needs to be least to greatest with nothing repeating. So it's going to be negative 4, negative 1, 1, and 3 for my domain. My range is going to be negative 1.5, negative 0.5, 1, and 1.5. And then we're going to tell whether or not it's a function. So we can do several different things. We can see if we have x's repeating, and we do right here. We have 2 negative 1s. Or if I use the vertical line test for my graph and I draw a vertical line right here, it's going to touch in 2 points. It's going to touch here and here. Or if I look at my mapping, the negative 1 has 2 different arrows drawn from it. So this is not a function. So function, no. And for your explain, you can say 1x is paired with 2y's, or you can tell me that it fails the VLT since you have a graph. So make sure you have all that down before you move on. Now we're going to move on to our pictures. With our pictures here, it's just wanting us to state the domain and range and tell whether or not it's a function. So for number 4, with domain and range, for this one it's a little bit different. I can't just tell all of the x values that it has because it's all those x values and all the numbers in between those x values. So what I'm going to do for domain and range here is for domain, I'm going to look at the leftmost point of my picture, and I'm going to look at the rightmost point of my picture. The leftmost point is right here, and it's at negative 1, negative 2, negative 3, negative 4. So the left-hand side's at negative 4, and then I'm going to look at the right-hand side. It's at 1, 2, 3, positive 4. So negative 3 and positive 4. So for my domain, to show that it's all from negative 4 to positive 4 and all the numbers in between, I'm going to go back to my AND set notation that we looked at for inequalities. So there's my AND set notation. I'm going to put these from least to greatest, so it's everything from negative 4 to positive 4. I'm going to basically do the same thing with my range, but I'm going to go from the bottom of my picture to the top of my picture. The bottom of my picture is at negative 1, negative 2, negative 3. I'm going to look at the top of my picture, 1, 2, 3, so it's at a positive 3. Again, I'm going to set up my range in my AND set notation, but I'm going to use y's because range is talking about the y values. And I do have the extra mark here because of the fact that these lines are solid. And it's going to go from negative 3 to positive 3. So that shows that it goes everywhere from the bottom part of our picture to the top part of our picture and all the numbers in between. Then if we're talking about a function, we're going to use the vertical line test since it's a graph. And if I draw a vertical line right here, it hits my picture 2 different times. So it is not a function. So function, we're going to say no, and we're going to say that it fails the VLT. It fails the vertical line test. Alright, for number 5, again for domain, we're going to look at the leftmost point of our picture and the rightmost point of our picture. Let me give you a minute, make sure you've got number 4 written down. Alright, so again we're going to use our AND set notation for domain. So I'm going to look at the leftmost point of my picture. It's at -1, -2, -3. Now look at the rightmost point of my picture, and it's at a +2. I'm going to put it into my and set notation. Now this time I will not have extra marks underneath my two less than symbols because of the fact that this circle is open and the circle up here is open, which means that the -3 and the 2 are not included in my answer. So we're going to put -3 and 2 with no lines underneath the less than symbols. Then with range, again, use the variable y because we're talking about the y values, and I'm going to go from the bottom of my picture to the top of my picture. So that's going to go from -1 to 3. So again, I'm going to put my two less than symbols. They're not going to have the extra marks because of the open circles, and it's going to go from -1 to a +3. Now this one, if we use the vertical line test, no matter where I draw a vertical line, it's only going to hit that graph in one place. So we're going to say, yes, this is a function. And it's a function because it passes the VLT, or the vertical line test. All right, number 6, again, you make sure you got number 5. All right, number 6, again with the domain are our x values, so I'm going to go ahead and set that up and into an and set notation since I have a picture. This time I am going to have the extra marks because both of these circles are closed. So again, domain, I'm going to go from the left point of the picture to the right point. My leftmost point is at -2, and my rightmost point is at 3. So I'm going to go -2 to 3 for my domain. And that tells me that at those points and all the points in between. Then for the range, it's my y values. And I'm going to go from the bottom to the top. And the bottom part of my picture is at -3, and the top part is at +3. So my range is going to be -3 to +3. And again, with this one, no matter where I draw a vertical line, it's going to pass the vertical line test because it's only going to hit in one place. So I'm going to say yes to the fact that it's a function, and I'm going to say that it passes the VLT. Make sure you have that one down before you move on. Alright, last one. Domain, again, is my x values, and since it is a picture and not just a set of points, I'm going to use my and set notation, and that's how you know the difference. If they're asking for domain and range of an actual graph picture here, you're going to use the and set notation. If you're just given points, you're just going to list the x and y values. So here on my domain, I'm going to go from the leftmost point to the rightmost point. So my point's at 0 and 1, 2, 3, 4. So it's going to go 0 to 4. And then with the range, again, make sure that you're using the y because the range is talking about y values. It's going to go from the bottom part of my picture to the top part of my picture. So that's going to go from -2 to 4. So -2 to 4 for that one. If I use the vertical line test and I draw a vertical line right here, it's going to hit that picture in 2 different places. So it is not a function. So no, and we're going to say it fails the VLT. Alright, that is the end of your notes for today once you have all that written. Thank you for watching.